Halo, perkenalkan nama saya Purna Dwi Mata, NIM 209. Di sini saya akan menjelaskan tentang resolution spatial.
Let's talk about spatial and contrast resolution and how it affects the digital image. But first we need to know what the definition is of spatial resolution. Spatial resolution refers to the ability to differentiate two objects. Basically, how tiny can an object get, and we can appreciate its difference from another object. Having low spatial resolution will make it difficult to differentiate between two objects that are relatively close together. Here, we notice that this nodule looks different than lung and different than rib. If this image had low spatial resolution, the provider would not be able to tell the difference between that nodule and the rest of the rib. Spatial resolution can be measured by the way of spatial frequency. We use the expression line pair per millimeter. A line pair consists of one dark line and one light line. Where on this phantom do the lines begin to blur together? At that point, you would say, the spatial resolution has gotten so low that I can't differentiate the two objects. Let's zoom in on a single line pair. Now we'll draw two lines to represent one pair of lines, also known as a line pair. Now our drawing represents one line pair per millimeter. The drawing on the left is one line pair per millimeter, and the drawing on the right is two line pairs per millimeter. We can keep on going, and now we have 5 line pairs per millimeter. Things are just getting out of hand. 40 line pairs per millimeter? That's ridiculous. Remember, spatial frequency is a measure of how small you can see an individual object. So for example, if we have one line pair per millimeter, we're actually seeing 2 lines per millimeter. So if you take the reciprocal of that, then you're actually being able to see an individual object that is 0.5 millimeters. At one line pair per millimeter, you can distinguish an object that is 0.5 millimeters in length. At 2 line pairs per millimeter, you can distinguish an object that is 0.25 millimeters in length. At 5 line pairs per millimeter, you can distinguish an object that is 0.1 millimeters in length. Humans normally can see about 5 line pairs per millimeter, or objects that are as small as 0.1 millimeter in length. What's the smallest line pair you can see? I can see about 2.75 line pairs per millimeter. Unfortunately, with this image, I can't see all the way down to 5 line pairs per millimeter. Spatial resolution is affected by factors that happen before X-rays hit the image receptor and factors that happen after X-rays hit the image receptor. Factors that happen before X-rays hit the image receptor are things affecting beam geometry such as SID, OID, and effective focal spot. Increasing SID increases spatial resolution because it decreases penumbra. Increasing OID decreases spatial resolution because it increases penumbra. Increasing the effective focal spot decreases spatial resolution because it increases penumbra. And what is penumbra? Penumbra is the area of unsharpness around an object. So for example, if you increase SID, you'll decrease penumbra. If you increase OID, you'll increase penumbra. And if you increase effective focal spot, you'll also increase penumbra. Two factors that affect spatial resolution after X-rays hit the image receptor are pixels and matrices. A pixel is the smallest unit of a digital image. Let's take a look at Charmander here. As we zoom into Charmander and zoom even closer to his eye, we can see that his eye is made up of individual pixels. If you were to increase the physical size of the pixels, like in the far right image, you would notice that there is a decrease in spatial resolution because the large pixels cannot resolve nearby structures. A matrix is the layout of pixels in rows and column and the total number of pixels in the image. For example, Charmander's eye has a matrix of 4 pixels across and 5 pixels high for a total matrix size of 20. Increasing matrix size increases spatial resolution. Charmander on the left has a matrix size of 378, and the one on the right has 1330. Because Charmander on the right has a higher spatial resolution, we can resolve individual flames in their tail, whereas the one on the left looks like there's only one flame. To put this in perspective, the iPhone 11 Pro on the left has a matrix size of 1125 by 2426, and the iPhone 11 Pro Max has a matrix size of 1242 by 2688. The left iPhone has 2,729,250 individual pixels, and the right iPhone has 3,338,496 individual pixels. So, an increase in spatial frequency or an increase in line pairs per millimeter increases spatial resolution. Or, as spatial frequency increases, we are able to resolve smaller and smaller objects. So we'll switch gears and talk about contrast resolution. Contrast resolution is the ability to distinguish structures with similar subject contrast. For example, being able to tell the difference between fat or muscle, or the difference between a liver or spleen. Regular diagnostic radiography does a poor job at this, but CT and MR have excellent contrast resolution. Contrast resolution is also affected by factors that happen before X-rays hit the image receptor and factors that happen after X-rays hit the image receptor. Factors that happen before X-rays hit the image receptor that affect contrast resolution are KVP, grid ratios, and collimation. Increasing KVP decreases contrast resolution because of the increase in scatter production. Increasing a grid ratio increases contrast resolution because of the decrease in scatter reaching the image receptor. Finally, increasing collimation, or decreasing the field of view, increases contrast resolution because of the decrease in scatter produced. One factor that affects contrast resolution after X-rays hit the image receptor is bit depth. Bit depth is the number of shades of gray a pixel can represent. For example, a 2-bit system can show 4 grays, but a 4-bit system can show 16 grays. The formula to find the amount of gray values is 2 to the power of the bits. For example, when we say a system is 4-bit, that means it has 2 to the power of 4 number of gray values. With classic film radiography, there are about 1,000 different shades of gray, but with digital radiography, there are about 16,000 different shades of gray. This is one of the greatest advantages to digital radiography over classic film radiography. So, increasing bit depth increases contrast resolution. But be careful, this is not an increase in image contrast. Increasing contrast resolution means you're increasing the ability to distinguish many shades of gray. Here are all the factors represented at once. Factors that happen before X-rays hit the image receptor are represented in the yellow box, and factors that happen after X-rays hit the image receptor are represented in the purple box.